Just like the lighting analysis module, which we reviewed in the previous video, the question of controlling plug loads is also a potential energy saver in modern buildings. The question there is, how would an occupancy sensor, if added to the control system of outlets, affect energy savings? And the setup is fairly similar to that of the lighting load module, slightly different because the inputs are not lighting density levels, but an actual power meter on an outlet strip. So the way this works is you would send an engineer to the building, set up a temporary occupancy sensor, set up a temporary power meter, analyze that data, and then figure out what the savings would be if you automated the process. So the UT has a way of analyzing that. We'll use some sample data just like we did for the light loads and look at the sample data that comes with the UT. In this case, we're going to look at the plug loads, and we'll take those two text files, drag them right into the sources, and make a quick chart to look at the data. Right click for a new line chart, double click the chart, and then simply drag the channels in here. So there's the actual power use as measured on the outlet strip with a temporary meter, and then the occupancy voltage from a temporary occupancy sensor is shown in red. As we did before, we're going to add a pane to this chart and move the occupancy sensor down into it for a little bit more clarity. Okay, the current operation shows a weekend, and then this is Friday, Thursday, Wednesday, Tuesday, and then Monday, Tuesday, Wednesday, and so on. And let's look at one of those days in a little bit more detail. So the occupancy sensor shows that clearly somebody's at the desk, maybe shortly out during lunch. So there's less occupancy sensing signal here. And the PC that we're monitoring here, the computer power, appears to be in sleep mode or something close to it with about 49 watts of power draw at night. And then during the day when it's actually on, it peaks at about 140 watts. So the idea would be, of course, if we made an occupancy sensor permanent, that all these nighttime draws would vanish. Okay, so to analyze how that would look, let's pick a plug load analysis module, make a new one with a right click, double click that. There's some short instructions here. Again, as we did for the light load, we'll pick the root folder because the two channels that we're looking at are the only ones we have. The occupancy channel is the voltage that we get from our temporary sensor, and the computer power channel comes from our power meter here. So in setting up what a control system would do if we automated it, we would say that the occupancy signal that we consider a good trigger for someone actually being there might be around 1. So 1 volt might signal somebody's actually at the desk and moving around. So I'm going to say 1 volt. A turn off time for typical occupancy might be something like 30 minutes. That's not a bad choice. And if I look at the level that I consider to be on for the computer, obviously the 45 or 49 watts that we saw here earlier does mean that the machine is on. So, and when during the weekend when that person apparently does turn the computer off, I'm seeing a 7 watt draw. So that might be LEDs or some battery backup inside the computer or something. So I'm going to say anything between those two is what I would call a occupied state. So let's say 25 watts would be a good trigger level to say anything above that, if it gets turned off, would constitute savings. Then I'll analyze this, and all the periods at night, not surprisingly, that I see no occupancy signal, so the red line here is off, shows a potential 50 watt savings. So analyzed over the course of a year, this would come to something like $26 for this one terminal. This is all very similar to the lighting load analysis we did a little bit earlier. And as we saw there as well, there's a slight potential waste here. We can take a quick look to make sure we understand this correctly. The waste would occur on a Monday morning, so we're looking here at October 11, 1999, 8 a.m., and we see the occupancy signal has already triggered, but in our current example, the computer hasn't actually been turned on yet. Let's just verify that in here. So the Monday morning occupancy sensor here is triggered, so somebody's walking in and they're in the office above the 1 volt threshold at 8:15, but the computer only turns on at about 8:30. Simply means somebody walked in on a Monday morning and didn't turn the computer on immediately. So that's fine. Our control system would have turned on the computer immediately and wasted this 15-minute window. But overall, as in the previous analysis, overall the blue areas far outweigh the red areas. So if we implemented a automatic system with the same trigger levels, they would save something like $26 a year for this one workstation.